Let us continue from where we stopped yesterday. Yesterday we started talking about what is ratio. Ratio is the comparison of two quantities. Okay? Then there are a few rules about ratio. There is no unique one at the simplest form because we can only compare the same measurements. So they will be, when they have the same unit on both sides, it will be cancelled away. So the simplest form of a ratio got no unit. It is purely a number, a proportion of the relationship between two quantities. Then ratio is very much like fraction. Then I told you all when we reach this question, one difference, we cannot compare three quantities when we write it in a fraction. But ratio, we can compare three quantities at the same time. Okay? So when we have three numbers like that, we are comparing, we are saying that the proportion of each of the quantity is related to both the other quantities. Okay? So all of their proportion will change together when we have three quantities. 150 is to 80 is just like 80 is to 100. It is also just like 150 is to 100. Okay? So there are three quantities here. Okay, let us give it some actual quantity so that it is easier to see. So maybe 150 is the number of children or number of students that is wearing red. 80 is the number of students that is wearing blue. 100 is the number of students that is wearing white. So this is the ratio, number of students. 150 is to 80 is to 100. Okay? Then it can be simplified or you can look at it individually. If from this information I want to know what is the ratio of students wearing red to students wearing blue, they can be individually written down also. Red to blue is 150 is to 80. Blue is to white can be 80 to 100. Red is to white will be 150 is to 100. So individually, when in pairs, it is true also. When we are given this, we can look at it. Red with blue is like that. Blue with white is like that. Red and white, I can take them out and then form another ratio also. Just that when they are written like that, it puts all three values together. Then we can work with it together. Okay? So the simplifying part of it is still the same. So the simplifying part of it, whenever we change one of them by multiplying or dividing, we have to change the others also. Which is why the earlier example, 5 is to 25, we divide both sides by 5. Then now we got three values, so we have to divide all of them together. When I divide one, I divide the other one, I divide the third one also. So in this case, the fastest, easiest one to see is that all of them got a 0 behind. When all of them got a 0 behind means we can divide it by 10. Okay? So if I divide 150 by 10, I get 50. Then I want to divide the first number by 10, I have to divide all the other numbers by 10. Okay? Then I try to see if there are still any common factors, things that they all can divide by. easiest to think will be 2. Then 15 cannot divide by 2 already. Odd number cannot divide by 2. Then any other common denominator, this one can be divided. All of them cannot divide by 3. This one can divide by 5. This one can divide by 5. This one cannot. Then after that, no more already. So this is the simplest already. Okay? Okay, so this one more rule for ratio. Simplest form cannot have decimal, cannot have fraction. So in this case, there are decimal. If I don't want any decimal, fastest way is to multiply by 10 first. When I multiply by 10, this one will become 18 instead of 1.8. Then no decimal already. Similarly, multiply by 10.6 will become 6. No decimal. 7.4 I multiply 10 will become 72. Also no decimal. So the easiest way is to multiply 10 first to everything. You want to multiply 1, you have to multiply the same thing to all the others. Okay? So now at least I satisfy no decimal, no fraction. Then I have to still see if they can be divided by common factors. All are even numbers, 18, 6, 72. So I can write the next line. All can divide by 2, I divide all by 2 first. Now that I divided all of them by 2, then I think again, can I still divide, simplify further? 2 cannot already. These 2 are odd numbers. What is the next number that I will try is 3. Then 9 can divide by 3, 3 can divide by 3, 36 can also divide by 3. So I will divide all of them by 3 also. Then become 3, this is 1, this is 2. Once any of them reach 1, cannot divide further already. Okay? Because we divide 1 by anything, it will also, anything bigger than 1, it will also become decimal already. Then we go 1 decimal. So when any one of the number reach 1, that means that is the simplest form. Okay, so think of it, ratio. What is the purpose? What does ratio actually tell us? It actually tells us one quantity compared to another quantity, how many times is it? Okay, the relationship is all by multiplication and division. So I write here, if let's say boys to girls is 1 is to 2. It is telling us there are 2 times of girls to boys. Okay? Because it is in the simplest form. So it can be 1 boy is to 2 girls. It can also be 2 boys is to 4 girls. What doesn't change is that it is always 2 times. Or how many multiples of it. So the relationship for ratio is that it tells us how many times more or how many times of one quantity is of the other quantity. Okay, this is the main idea when we talk about ratio, the proportion, how many times of something. Okay, then let us look at question 2. reminded me of the example I gave yesterday between kilometer and meter. Then I think it is very good if you try, like yesterday Aska say kilometer and meter different, then I think it is a very good attempt because it was from what I say. I say have to be same unit. Then she say kilometer and meter different. So at least I know that she is paying attention, she is processing, she is learning. Okay? Although it is a bit of a trick, but I think it's very good. You try, and then after that I'm sure she will remember even better. Okay? So this time it is similar to that question. Now we have meter is to centimeter. Ratio of 2.4 meter to 204 cm. Okay? So we can start by writing. They want us to find the ratio of 2.4 meter to 204 cm. So in this case, 2.4 meter comes first, followed by 204 cm come behind in the sentence. So we will write the first one, the in front one at the left. So we will write the ratio is 2.4 meter is to 204 cm. It follows the order. Then it comes to the next point. Ratio have to be same unit, or ratio must be measuring same things. So now we have meter and centimeter. So we cannot continue when they are different. We have to make them the same. Every 1 meter is the same as 100 centimeter. Okay. All this conversion we have to know. So when we look here, on the left is 2.4 meter. There are 2.4 times of 1 meter. Meaning that every 1 meter is 100 cm. So if I want to convert it, 2.4 meter is like having 2.4 times of 100 cm. If you know your conversion very well, you don't need to write this bracket, it is okay. But if you still picking up on this conversion, 2.4 meter is 2.4 times of 1 meter. Then every 1 meter is 100 cm. That's why 2.4 times 100 cm. Then after that you can convert from meter to centimeter already. Then 2.4 times 100, we move the decimal point 2 times to the right. Okay? Every time I times 10, this is like moving this decimal here. Because times 10, 2.4 become 24. Times another 10, it will come to 240. I move the decimal point 2 times like that. The multiplication is like multiplying the decimal point 2 times. Okay, so I will have 240 cm is to 204 cm. When both sides same unit, then the next line I will not write the unit anymore. I will just leave the numbers already because ratio no units. It is only a comparison of numbers. Then 240 over 204, you can slowly go and divide. But I told you yesterday, there is one more way. I just key this inside my calculator as a fraction. Then my calculator will help me do the division. So I key in, press fraction, then key in the numbers 240, 204. Then my calculator give me, this time I key the bigger number on top. Whatever is on the left, I just key 240 on the top, 204 at the bottom. Then my calculator show me 20 over 70. Okay? So what I key in inside the calculator is like that. I key it as a fraction, 240 over 204. I press equal, my calculator shows me 20 over 70. Calculator. So the calculator is telling me 240 to 204 is the same as 20 is to 70. Then I can simplify already. 20 is to 70. Okay. Okay. So you can see that finally simplest form only numbers don't have unit. So when they give us different unit, we convert the same unit, then simplify to just numbers. This is a very important, basic but very important question. Always come out one. Okay, for question 3, write down two equivalent ratios of 11 is to 12. Let me add some storyline to it, then you can think of it easier. So let's say we are talking about wearing specs to not don't wear specs, and the ratio is 11 is to 12. When you read this, does it mean that there can only be 11 that wear specs and 12 that don't wear specs? When we say the ratio is 11 is to 12. So let's say the class, we are talking about one class, then inside the class, the wear spec to don't wear specs one is 22 is to 24 then you will get the ratio as 22 is to 24. But when we simplify it to the simplest, both sides divided by 2, it will be 11 is to 12. Okay? So when you see the ratio as 11 is to 12, it doesn't mean that there is 11 that wear, 12 that don't wear. It can be 11 that wear, 12 that don't wear. It can also be 22 that wear, 24 that don't wear. Okay? By the same idea, it can also be 33 that wear, 36 that don't wear. Okay? So, all these ratios, 33 is to 36, 22 is to 24, 11 is to 12, they are called equivalent ratio. Meaning, they end up, they tell the same story. They tell you the same proportion. Okay? Okay? So this is the meaning of equivalent ratio. So when I'm given 11 to 12, how did I get this? I just multiply. As long as I multiply the same number to both sides, I will get more equivalent ratio. So 22 to 24 is when I multiply by 2 to both sides. Then I get 22 is to 24. If I multiply 3 to both sides, then I got 33 is to 36. I can write down there are endless equivalent ratios of 11 is to 12. Can be times 4, can be times 5, times 6, times 7. All these are equivalent ratios. They tell the same story. And all of them can be simplified to the simplest 11 is to 12. Go, go, go. Okay, this next question is more difficult in terms of the understanding. X is the same as 3y. Then does it mean that x to y is 2 is to 3? Anyone want to make a guess? Yes, no? Or you cannot prove one? How? Do you all think it can? Do you think there is an actual answer, yes or no?
Yes.
Yes. Then is it yes or is it no?
Yes.
Yes. Okay, Almir say yes. Anyone say no? No. Aska say no. Okay, so one of you must be right, one of you must be wrong, unless there is no actual answer. Okay, let us take a look. 2x is the same as 3y. Left and right equal sign is same. So if 2x is 3y, if I divide the right side by y and I divide the left side by y at the same time, they will still be the same, correct? I divide both sides. The same thing, I do the same thing, so they should still be the same. Okay? Then it will become 2x over y equals to 3. Correct? Then if I now divide both sides by 2, left and right are still the same. Left and right are the same. I do the same thing, so the left and right still the same. Then I continue to divide left and right both by 2. I do the same thing, so they should still be the same. So what I'm going to do is I divide left by 2, I divide right by 2. Then 2 and 2 cancel. 2x divided by 2 is no more 2 already. So my left side will be left with x over y. My right side will be left with 3 over 2. Okay, remember ratio is just like fraction. So the proportion of x is to y is the same as the proportion of 3 is to 2. The proportion of x divided by y is the same as 3 divided by 2. So if we change this fraction to look like ratio again, that is to say x is to y is the same as 3 is to 2. Okay? So there is an actual answer whether yes or not. So if we look back, then x is to y is 2 is to 3 is not correct. Because x is to y is the same as 3 is to 2, not 2 is to 3. So there is, you can slowly go by your equation, doing the same thing on both sides to get to the answer. Okay? So sometimes we have to change and use ratio. Sometimes we have to convert it into fraction to get to our answer. But this one usually won't come out in your exam. But I want you all to know ratio and fraction, they work in the same way. Okay, Ken? Good try, Amir. Be brave enough to try make mistake lah. You make mistake, you will learn from your mistake. If you don't even think, you don't even try, you will be stagnant. What you know now will be same as tomorrow, next year. Then you forever not learn. So try, make mistake. Wrong is okay, learn from it. Making mistake doesn't mean you die. Right? Chinese got a saying, mistake is the mother of success. You have to make mistake, then you will be able to taste success. Okay, this one we quickly let you all think about it. Which of these are equivalent? If don't because got P, got Q, got alphabet, then you become scared. They mean the same thing as just numbers. If there is a ratio, some number to some number, does it mean that I square both sides, it will still be the same ratio? First one, we think about this one first. First one. P and Q. They give you P and Q, but it can be any number. Okay? So for example, if I want to work with this P, after squaring both sides, will it still be equivalent? P and Q, is this the same? Some of you shaking your head. So the rest got think or not? If you cannot decide, why not? You put in some numbers, then you try. Let's say I have 1 is to 2. This P square and Q square, what it means is I square both sides. I square what is on the left, and then I square what is on the right. So if I start with 1 is to 2, if I were to square both sides, I will have 1 is to 2 square is 4. Are they equivalent in ratio? Equivalent ratio means they must be the same proportion. 1 is to 2. The equivalent ratio will be 2 is to 4 and not 1 is to 4. Okay? So is this equivalent? Arik? Don't know what I asked. You know that is the problem. The problem is not when exam you cannot answer. The problem starts when you are not listening in class. Very happy, talk to each other. Now you happy for 1 hour. Then when exam, your result come out, then unhappy for a few days. Or until national exam, fail your math, cannot go to where you want to go. Then pay for this with the rest of your education. Okay, so from P is to Q, they are asking you if P square is to Q square is an equivalent ratio to P is to Q. So if you cannot decide, you don't know what is happening, P is to Q, instead of P is to Q, you think of some numbers to substitute. Easiest numbers, let's say 1 is to 2. What it means, when they say P square to Q square is they square both sides. From P become P square is I square P. From Q become Q square is I square Q. So if I start with 1 is to 2, if I were to square both sides, 1 square already is 1, 2 square already is 4. So are they equivalent equation? That was the question I asked. So I read now, yes or no?